Precalc, Chapter 1, Section 2. So tonight's video, our goals, we're going to decide if relationships are functions, talk about domains and range, and then we're going to evaluate functions and difference of quotients, which is a tough concept. A function, f, is a relationship where every element x in set A relates to exactly one element in set B. Now, we talked about functions before in math. The difference in this one, this definition from previous years, is that every element in X has to be used. And so we kind of add that in part of the definition of function notation or functions for this class. So representing a function, we can look at a verbal, table, graphing, and then algebraically 4 different ways to describe a function. And so a verbal description of a function, so if we look at a cookie, if I give good old Joe Schmo a cookie and we see what he does with it, if the input's the cookie then the output is who eats it, so Joe gets the cookie, that's a function because that one cookie goes to one person. But if Joe and John, if they share the cookie, they split it in half, now it's no longer a function because that cookie goes to 2 people. So that's not a function. So you can do it through a verbal situation. A description is one way, so we'll keep it a function. A table, so you can look at it through a table, and we can do the table horizontally, you can do it vertically, doesn't matter. So every value of x goes to exactly one value of y. So for this, if this wants to be a function, I have a 1x here, goes to 2. This one also has to go to 2. That would still be a function. These x values, I couldn't have these ones go to different y values. We can show it graphically, and we look at a graph. So we look at a good old parabola here. We look for the vertical line test. If you draw a vertical line through the graph, it doesn't matter where you draw it. Every vertical line you draw will only hit one point. So that's the vertical line test. We should recall that from previous math. It tells us if it is a function. And the last one is algebraically. And so we just look at a basic function, y equals negative 2x plus 3. I know it's a function, and that's because I started knowing families of functions. This was a linear function because I know it's x to the first. Another way to look at functions are through mappings, and so we can look at it through just matching a number from the left column, the inputs, to a number in the right column. And so here, is this a function where the negative 2 goes to negative 3, negative 1 goes to negative 3, 1 goes to 1, and 2 goes to 1. This would be a function. Even though they only go to 2 of these values, each value from the input goes to 1 value from the output. So that is a function. So yes. As soon as that number 2 or one of these values go to a second number, then it's not a function. Or if I didn't have a line from one of these inputs, it would also not be a function. So we want to test equations. We want to see if an equation is a function. We can solve for y and then look for double answers. The double answers, because again we're getting these like 2 points here. X goes to 2 different y values. Those would be the double answers. So this first equation right here, if we solved it for y, we get y equals, again, subtract x squared, divide by 2. So we'd have like negative 1/2 x squared. And we have 4 divided by 2 would be 2. So if you actually went through the solving, you'd find this. And there's no double answer. Y is one value. So if I plug an x value in here, I get one answer for y back. So that would be a function. But let's look at this other one. This second equation right here, and if we solve that for y, so we just subtract x squared to both sides, so y squared equals 8 minus x squared. The next step is to square root both sides. When you square root that, you find y is equal to plus or minus the square root of 8 minus x squared. So now we're getting 2 answers here. If we plug an x value, we're going to have a positive and a negative answer back to us, which means that this is not a function, no, because we have 2 y values for 1 x value. So you can look at the equation for the double answers when y is solved. Some of the notation we'll talk about. F is just the function name. The function name. So it doesn't have to be F. It could be G, H, any letter. We typically start in that range of letters, F, G, and H. X is the input, and then f of x is the out. It's like y. And so f of x is a single value. It's not f times x, it's just one value, it's like y. So we can evaluate it. So we can do the f of x equals 10 minus 3x squared. So we want to find f of negative 4. It's telling us to plug negative 4 in for x. And so just doing that mentally here, this square only goes to the x values, but it goes to the whole number. So negative 4 is x, so it's a negative 4 squared, or negative 4 times a negative 4, which is 16. 16 times 3 is 48, and 10 minus 48 is a negative 38. So you can evaluate that by just plugging and chugging through it. The other problem here, f of x minus 1, so this is actually having us punch in a quantity for x. So when I write this, f of x minus 1, it's equal to 10 minus 3 times x squared. But we're plugging this whole thing in for x. So we put in x minus 1 for x. And we're simplifying this, x minus 1 squared. Make sure you realize that this square goes to this entire quantity, which means you have to FOIL it. And so you're going to get x squared minus 2x plus 1. And so don't forget about this middle term here, which I call OI. It comes from the outside inside of FOILing when you do x minus 1 squared. We need to distribute the negative 3. So we have negative 3x squared plus 6x minus 3. And then we can combine the 10 and the negative 3 to get negative 3x squared plus 6x plus 7. And so this would be the function for f of x minus 1. And so we can just use the substitution to simplify. For piecewise functions, we have two different parts, two different equations, and then you have the domain that works for that equation. So this first equation right here, we'll say in red, it works for values of x that are less than 0, so negative values. And then we'll call the purple equation here, the purple one is for x values that are greater than or equal to 0. So the first problem here is f of negative 2, and negative 2 is negative, which is less than 0, so I only use that top equation. So I'm going to plug it into the 3 times x minus 4, or negative 6 minus 4, which is negative 10. The second one here is f of 0. 0 is going to make this inequality true because it's equal to 0, so I plug it into the second equation, and we get 1. You only plug these into one of the two equations. You don't plug them into both. So implied domain, we have two different scenarios in math where we have to be very careful with the numbers we choose to plug in for x. So the implied domain is a set of all real numbers for which the expression is defined. So what works, what makes the equation true. And the two situations are if we're dealing with fractions and we're dealing with roots, even roots. So we're dealing with fractions. Our denominator, the denominator, cannot equal 0. And so when we're given a fraction, you mainly take the denominator, 4 minus x squared, set it equal to 0, and realize it can't equal that. So to solve this, I can add x squared to both sides, and then I can square root. If you square root both sides, you get plus or minus 2. Do not forget you have plus or minus whenever you square root both sides. And so these are the values that x cannot be, because we do not want it to be 0. So x cannot equal plus or minus 2. That is the domain for that first example. For the second one, for when we're dealing with even roots, we want non-negative roots. So what values of x make this root, this quantity, less than 0? It can't be that. Or we want this quantity to be greater than or equal to 0. So we can set that equal to greater than or equal to 0 and then solve that. So if I subtract 9, so I want to divide by negative to both sides, and I did it in this order to make sure you realize that when you divide by negative, you flip the sign here. So we have x squared equals 9. Now, this is a tricky part. You've probably never seen this in math, but when we square root both sides, we've always said in math that you'll get a positive or negative, and that's true, but we're skipping a step there. So what we really get here is when you square root both sides, it's actually the absolute value of x has got to be less than or equal to this answer 3. So you don't get the plus or minus right away. Now where does the plus or minus come from is solving this inequality here. So if you remember how to solve absolute values inequality, you write like x is less than or equal to 3, and then you also write x is greater than or equal to negative 3. you end up having both the positive and the negative, and you flip the sign. And so then these would be the two inequalities, which you can write as a compound inequality. And you could say negative 3 is less than or equal to x, which is less than or equal to 3, as the actual domain for this root. So x has to be between these two values to make sure that this radical is a positive value, so we don't have imaginary solutions. So that's the implied domain. Now for the tough part, difference of quotients. So this is the difference of quotients, this formula right here. And notice how we also state that h cannot equal 0. That's the implied domain, where we can't have the denominator of 0, can't divide by 0. So what this is made of, we have the subtraction right here. So we are subtracting, and we have the quotient by the division. So that's where the name comes from, the difference of two functions divided. And what we're dividing by and what we're subtracting is very special here. So I'll kind of give you a broad scope of what this is doing a little bit here. We have f of x. We're having f of x, and we're having f of x plus h. So it's kind of a very similar function. F of x is the same function. What we're doing is we're adding some value h, to our x value. And we're taking those two functions and then subtracting. And so x squared minus 2x plus 9, if this is our function, let's find this difference of quotient. So we know we're starting at the x value of 4, but we don't know the h value. So to find it, now that's the understanding, but let's look through the algebra here. So to find this, we need to realize what f of 4 is. We need to realize what f of 4 plus h is. So f of 4, we're just plugging 4 into this function. So that's 4 squared minus 2 times 4 plus 9. Just plugging 4 in for the x's in that equation. F of 4 plus h, I need to plug 4 plus h into the function. And I'm going to get this polynomial. And so we can simplify both of these. But what we're doing with these is we're going to put them into this formula and have the difference of these two. So we're going to be subtracting these two, and be very careful with your parentheses or grouping. So if I simplify this top, I get 16 minus 8, which is 8, and 8 plus 9 is 17. If I simplify this one, I actually need to FOIL this, so I get 16 plus 8h plus h squared. Distribute the negative 2, so negative 8 plus, or actually minus 2h plus 9. If I combine my terms, I get h squared, and then plus 6h, and then we have plus 17. So that's the function f of 4 plus h. Now let's plug them into our difference of quotient. So the first one, f of 4 plus h, is this quantity right here. So I'm going to take that quantity, and then with that I'm going to subtract the f of 4. So subtract, and make sure you always put parentheses around this. F of 4 is 17. And that whole thing is divided by h. And so we need now to simplify. Well, 17 minus 17, that's just 0. So I end up with h squared plus 6h over h. Well, the numerator both has an h in the term, so let's factor out an h. I'm left with h plus 6 all over h. And those two h's, now we have multiplication between these two, I can reduce those h's, so I end up with h plus 6 as the final difference of quotient value. So I want to do the same thing here. I want to find the difference of quotient of this function. Now for this one, it's a little different because the difference of quotient, f of x plus h minus f of x all over h, is the general name. Now it doesn't matter if I call it f or g. This one's just called g for a different function. You need to substitute that in there. Now notice how we don't know the x value. X value is not a number. So you actually need to use all of x plus h for the substitution, the first one. And then we do it again for just put in x, which is g of x, the same thing when you do that substitution. So this is going to be your homework problem for the video. I want you to try completing this and finding what is the difference of quotients for this problem. And so give that a shot. Look back at my previous problem if you need be to try to help you out. Let's see how far you can get on the substitution, and we'll start the day off tomorrow with this problem. So call that good. Have a great night. See you